Advanced modules and packages in Python allow for the creation of multi-file modules, essential for scalable projects. By organizing code into separate files, developers can manage complexity, enhance readability, and facilitate collaboration. This modular approach supports reusability and maintainability, crucial for large-scale applications. Python modules and packages are essential for scalable architecture. Modules are single files containing reusable code, while packages are directories with multiple modules. They enhance code organization, promote reusability, and support the don't repeat yourself principle. Understanding these components is crucial for building efficient, maintainable Python projects. A Python module is a single .py file containing definitions and statements, enabling code reuse across projects. Modules encapsulate functions, classes, and variables, promoting DRY principles. The module's name is the file name without the .py suffix, and best practices suggest using lowercase with underscores for readability, like data_processing.py or user_authentication.py. A Python package is a directory with multiple modules and an init.py file, allowing Python to recognize it as a package. This structure groups related modules, creating a hierarchical namespace to prevent naming conflicts. The init.py file marks the directory as a package and can execute initialization code upon import. Multi-file modules enhance code organization by dividing functionality into logical units, improving maintainability. This modular approach allows teams to develop components independently, minimizing conflicts. It also promotes collaboration by facilitating code reuse and reducing duplication, ensuring consistent implementations across projects. Single-file modules, like module.py, are ideal for simple utilities, but can become cumbersome as complexity increases. In contrast, a multi-file package, such as mypackage/, organizes code into logical modules, enhancing scalability and maintainability. This structure allows for clear separation of functions, classes, and constants, promoting efficient development and collaboration. Creating a multi-file module involves organizing code into a package structure. Start by creating a root folder, such as mymath, and add an empty init.py file. This file signals Python to treat the directory as a package, allowing for organized imports. This structure enhances scalability and maintainability in Python projects. Begin by creating a folder named mymath in your project directory. This folder acts as the package root. Next, add an empty boxed init.py file inside the mymath directory. This file signals Python to treat the directory as a package, allowing import statements. While Python 3.3 Plus supports namespace packages without $:init_period.py, including it is a best practice for explicit package definition. Add module files to your package for specific functionalities. In arithmetic.py, define functions like add, subtract, multiply, and divide, ensuring error handling for division by 0. In geometry.py, include functions for calculating area and perimeter, such as area, circle, and perimeter, square. This modular approach ensures a clear separation of concerns, enhancing code maintainability. Using init.py in the mymath package, we import key functions like add and subtract for easier access. Relative imports, such as from .arithmetic_import_add, streamline module referencing. This setup allows users to import functions directly from mymath, enhancing usability. The $all variable defines the public API, ensuring controlled imports with from mymath import. The arithmetic module in the mymath package offers essential functions: add, subtract, multiply, and divide. Each function handles integers and floats, with divide incorporating error handling for division by 0. This ensures robust arithmetic operations, crucial for reliable mathematical computations in various applications.